So I saw some people's work that was still doing way too much work. If you're using scanf, it's really doing all the work for you as far as parsing. You don't need to multiply by powers of 10 to convert to integers or things like that. So scanf converts to an integer, a character, and an integer, and stores those in n1 op and n2. Check the return value. We talked about that yesterday. If it's not 3, something went wrong with the parse. That's a -1. Otherwise, you can make a set of if statements. You can use a switch statement, whatever your preferred style is. But basically, depending on what the operator is, perform some arithmetic operation on n1 and n2 and return the result. And if the operator is not one of our recognized characters, just return a -2 saying it's an unknown operator. So something like that will work.
That's all in C?
That's C, yeah. Yeah, did you do switch statements in 121?
It's been a while.
It's been a while.
I didn't do switches, I did if statements.
So switch is really just a glorified set of if statements. You can switch on usually an integer or a character, and then say case and list of value, colon, and whatever comes after that colon will be executed if the thing in the switch statement matches that. Normally we have break statements in here which says get out of the switch statement, because if you do something like this, right, if you have a switch statement like that where you're switching on, say, an integer I, if I turns out to be equal to 2, it will go ahead, it will do this instruction, this instruction, this instruction. It will also continue and do these instructions as well, right? It basically goes through the rest of it. So usually we put a break in here if we wanted to stop executing statements at this point, and then it'll jump out of the switch. If you have a return, that's as good as a break because it's going to exit the whole function at that point. But other than that, this is basically the same as, if I equals 1, do these things. If I equals 2, do those things, and so on. So it's just a shorthand. On some machines, switches are actually faster than if statements, but usually it's immaterial. All right, so questions about 416. Internet.
What's 416 about?
Some positive vibes. 416 is something we played with on the board, I think, which was removing x's from a string. So copy one string to another and remove all the x's. Yeah. I think this is pretty close to what I posted, but it's the right idea. So it's a function named remove, rem, that takes two strings. The first string is the input, the second one is the output, right? So you pass it a string that contains potentially some x's. You process that string and you modify that second string so it looks like the first one, but it has no x's in it. And you can use the string length function, but don't use any other built-in string functions. Okay, because there's things in string.h that will do a lot of this for you. And we worked through this somewhat. Right, if that's your input string, you'd like your output string to end up being just this. And if you don't see immediately how to do it, here's my suggestion, is think about this, just forget about code, think about it in just sort of plain words, right? How would you describe to somebody how they can take this string and turn it into that string, right? And you're talking to them on the phone, so you can't point and say, well, take that and copy it over there, right? You gotta do something a little more precise. So look at the first character. If it's not an A, save that in your output string. Look, it's not an X. Look at your second character. If it's not an X, save that. Look at your third. If it's not an X, save that. Look at your fourth character. Since that's an X, don't save it in your output string. Look at your fifth. It's not an X. Go ahead and save that in your output string, right? That's the basic high-level description. But look at your first, look at your second, look at your third. You got to find a way to describe that, right? And that's typically, if this is a character array called old, something like that, right? Have some kind of index and look at that character in your array and keep incrementing that index. That's how we move through input positions. And then storing it in your output string. Well, if this is new, we need to have some kind of index. And we can store into position j by saying new bracket j equals and then incrementing j. And then the small trick is, right, these don't necessarily happen every time through. Every time through we want to increase I because we're moving through the input array. But this only happens when we store something in that position. Right, so it's the thing with 2 pointers again.
So it only happens when, and the whatever I is not X.
Yeah, when old I is not X, then we
J
want to
only
store it into new
increases
j and increment.
Old I is not X.
Yeah. And then when you're done with all of this, right, we also need to throw a \0 on the very end because we're constructing a string. We don't know if there's a null terminator there already, so we want to throw one on at the end and work through the cases, and you'll probably find that if you're using j like this, just drop it in position j. So I would suggest writing something like pseudocode for this, right? Before you code it up, unless you've already done this. We did this sort of on the board last week. But think about the algorithm, right? What are the steps here? And then go ahead and turn that into C code. And that should get you there. So questions about this? All right. So we were talking about regular expressions yesterday, and we were playing inside VI, so we could use a slash to search for something. And this pattern could be a character or a set of characters. Could be a period which matches any character, that's a wild card. Could be a star which matches 0 or more occurrences of whatever comes before the star. Could be a caret which matches the beginning of the line, $sign that matches the end of the line. And I think that was pretty much all we did for patterns. And we said if you hit a colon, you can do a substitute statement, like substitute old with new. Or we could say substitute old with new. With a G at the end, what does the G do?
Global.
Yeah, it replaces every time that this old pattern occurs on the line, it replaces it with a new pattern. And we could also do first, comma, last. And then do a substitute command to repeat that command over a series of statements. And so we could say substitute the beginning of the line followed by 0 or more spaces with nothing, right? And that forces everything to be left justified. I don't know if this will work or not. So I'm going to substitute 2 spaces with 1 space everywhere on the line. Right, so I've just decreased my indenting level to 1 instead of 2. Or I can substitute every 1 space with 6 spaces. Right, but this also like spreads out my single spaces in the middle of other statements, which looks a little weird. So we can do basic substitutions like this, and we can search for patterns. So the real power of regular expressions is that we can not just search and substitute, but we can take the results of searches and use those in our substitutions. So I don't know. I don't know names. I'll just pick on our department. So so here's a file of names. And it may be that I want to turn these into email addresses, right? So an email address for faculty is first initial followed by last name. We can throw a period in the middle. We'll make these students. So I'd like Nick Macias to become N. Macias. I'd like John Doe to become J. Doe, and so on. So let me show you how we can do this. And then we'll talk about why this works. All right. I should have written that down before I did it. Okay, so here's what I did. Simple, right? Self-explanatory. So, when we do a substitution, we can group certain things that we're searching for, certain things in this old pattern, we can place them inside parentheses. And whatever matches that part of our expression is available to us to put into our new side. So let's do something a little easier. So let's just do what we did. So I want to find the first name, okay? And I know the first name is always followed by a space. So our name is something like Nick. and there's a space, Macias. So I'm searching for the beginning of the line, okay, followed by any number of characters, right, followed by a space. Okay, this pattern right here, a period, star, and a space is going to match this thing. So if I say substitute this with nothing, that will get rid of the first name. Right? I'm saying look for the beginning of the line, followed by 0 or more occurrences of anything, followed by a space. So however big that first name is, it's going to pick up all of those characters and the space. And if I say replace that with nothing, it's going to take that and it's going to get rid of it. Right? It's going to replace it with nothing. So if I say $1, $, substitute caret dot star space with nothing, right, there goes the first names. And if I said substitute a space followed by any number of characters followed by the end of a line with nothing, that'll match the space, and everything up to the end of the line, they'll get rid of the last name. Right, and there's no spaces at the end. But suppose I want to swap the first name and last name. So I can say, let's take the beginning of the line, match everything up to a space, and then match everything up to the end of a line. And what I'd like to replace that with is this stuff followed by this stuff. I'd like to take whatever matched after the space and put that as my output string, followed by, let's say, a comma, followed by whatever matched this part of the expression. So that Nick Macias becomes Macias, comma, Nick. Right? So here's what we can do with regular expressions. We can throw parentheses around these. And whatever matches this goes into something called register 1. And whatever matches this goes into something called register 2. And we can access the contents of register 2 by saying \2. And we can access the contents of register 1 by saying \1. And so I'm going to replace this pattern followed by a space followed by that pattern with the second pattern, comma, first pattern. And then just to keep it really interesting, these parentheses need to be escaped with backslashes, so these become \parens. So the whole thing is going to look like this. Substitute, let's say $1, substitute beginning of a line, parentheses, any number of characters, close paren, followed by a space, parentheses, any number of characters, close paren, followed by the end of a line with \2, comma, \1.
If you're escaping the parentheses used for grouping, how would you escape the actual parentheses?
A regular parenthesis will just match a parenthesis. And that's dependent on what you're feeding this regular expression into. Because there's lots of things that will treat this as an actual parenthesis, and if you don't escape it, it treats it as a grouping. But in here you have to use \paren to group. Okay, so first thing, don't ever try to read this stuff, okay? It'll make your brain explode. It's unhealthy. You write this stuff, right? We don't read it, right? I can't read this stuff. But try to understand why this is what was written, right? Beginning of the line, followed by any set of characters, followed by a space, followed by any set of characters, followed by the end of the line. And that's forcing this to match everything before the space and everything after the space. And then we're just replacing it with the stuff after the space, a comma, and the stuff before the space.
Missing,
I did something weird there, and there's no way to edit. Beginning of the line, bunch of characters, space, bunch of characters, end of line, \2, comma, space, \1. You never know if it's going to work till you try it.
And that's in VI.
That's in VI, but there's other places you can do this too.
You use like the same like S function or like the colon S for when you're in programming, or no?
What do you mean
Yeah.
in programming?
I was saying you'd have to treat the last name and the first name as separate variables or string of variables, right?
Mm-hmm.
Okay, never mind.
Like in a C program?
Yeah.
Yeah. So like in Java, we can do regular expressions, right? In
Mhm.
Perl, we can do regular expressions. Perl's actually like kind of built around the idea of regular expressions. Most modern languages have ways to do these kinds of quirky expressions, to do searching and substitution. Suppose I want to change this to just be n dot. I want to change every first name, which is at the end of the line, to just be the first initial followed by a period. Well, I can identify this because it comes right after a space. So I can say space, and I want to pick up that first character, and then a bunch of characters until the end. And since I want to save this first character, I'm going to throw that inside parentheses. And I'm going to replace this with a space, followed by whatever that first character was, followed by a period. So this is a way of throwing away everything after that first letter, basically. But the way we're thinking of it is we're taking this whole thing and we're replacing it with just the first letter followed by a period. Did you lose your internet?
Yeah,
Yeah.
for like the third time.
Yeah. Alright, so that should take the space, one character, and then all the rest of the characters. Throw all of that away, and in its place, put a single space, the first character, and a period. Now we got initials. So, so this is weird to try to figure out, right, at first. But it's a half dozen operators, right? Period, asterisk, caret, $, parentheses, and \, number for the thing that you're substituting with. But it gives you this hugely powerful mechanism for doing pattern matching and for doing editing of files, basically. There's a utility called sed that we'll talk about in a few weeks. It's a stream editor, and it gobbles up regular expressions and does things like this. And if you have a data file that you're trying to do some processing on, and it's not in exactly the form that you would like, right? It's pretty easy to do a few of these things once you know how to do it. and modify its format, right? Change it around. If it's comma separated and you want it space separated, if you want multiple spaces replaced by one space, if you want leading zeros added to things that have fewer than 5 digits, all this stuff, right? It's usually a single substitute command like this that will do that for you. So, so I'm not going to do a lot of testing on regular expressions, partially because they're really painful to try to read. But I want to mention them, and when we come back to SED, we'll deal more with them, and you'll see them. But I want to just kind of play around with these, which is hard to do without internet, because I would like you to be able to like try these things. But so is the basic idea making sense?
Yeah.
Yeah, right. So let's try some others, and then we got time for some board work. All right. So there's a text file. Suppose we want to just remove the first character from every line. So how could we craft something like that? Just take the first character from every line, get rid of it.
Use a dot, right?
Okay, we can use a dot because that'll match any character, right? It's a total wild card. If we want the first character on a line, how can we force that to match? Use the caret. So if we say caret dot, that's going to match the first character on a line. And if we want to get rid of it, what should we replace it with?
Nothing.
Just nothing. And I'm just going to do these all $1, just for dramatic effect. So we'll substitute on every line the first character with nothing. Right, it just gets rid of that first character. If we want to get rid of the first 2 characters, I just substitute 2 dots. All right, what if we want to get rid of the last character? Say again?
Read it until the last character on each string, or
Yeah, each line.
and when you read it till it comes to $1,
Yeah. So any character followed by the end of the line, right? Now, if I just do this, I'm saying replace the end of the line with nothing. That doesn't actually do anything, right? The $sign is kind of what comes after the last character. And it's not going to pick up the new line. It's just sort of an imaginary pointer that's saying, okay, everything that comes after the 9, we want to replace with nothing. Well, there's nothing that comes after the 9, so this isn't going to do anything, even though it claims it did. But if we say substitute any character followed by the end of the line, right, that's going to match the 9 on that first line. That's going to match the period followed by the end of the line, which is the thing after that. And on the second line, it's going to match the I followed by the thing after that. And if we substitute those with nothing, that will get rid of the last character on each line. And if we do this, it will get rid of that last character on each line and replace it with ha ha ha. Right? It's always a substitution. All right, so what if we want to get rid of the second character on each line? And forget regular expressions for a moment. Let's just think sort of description. What would you tell someone to do to get rid of the second character on each line? Take the character after the first. So we need to somehow pick up the first character, pick up the second character, right? And these substitutes, whatever we put over here is going to get completely thrown away and replaced with whatever we put over here. So since we're using that first character in order to get to the second character, this right here is going to get rid of the first and second characters. Well, if we only want to get rid of the second, we got to keep the first somehow. And this is where we can throw some parentheses in here. So when we do this, whatever this matches goes into register 1, which we can get to by saying \1. So if we replace this with \1, this says take the first two characters, replace them with the first character, which effectively gets rid of the second character. All right, so beginning of the line, find one character, find a second character. Replace those with the thing that matched that first dot, which was the first character. And so that gets rid of the second one. All right, what if we want to put the first character and the last character, and we want to swap their positions? So we want to swap the first character and the last character of a line. So how do we match the first character? Caret dot. How do we match the last character? Actually, $$. Right, so any character followed by the end. And we know we can throw these in parentheses so that we can save them. And we could replace them with whatever this matched and whatever that matched. Yes. Yeah. I didn't leave enough space. But we've got all this stuff in the middle too, right? We've got a bunch of characters between the first and the last, and we don't want to throw those away. We want to keep them, which means we have to match them and we have to put them inside a register. So how do we match all the characters between this first one and the last one? Star is part of it. Yeah, period star. Dot star. That'll match all the characters in between the first and the last, and let's throw that into a register. So this is in register 1, this is in register 2, this is in register 3. So what does this say? Match the first character of the line, put that in R1, followed by any number of characters, including 0 characters, put that in R2, followed by the end character, right? The character right before the end of the line, and put that into R3. And if we replace that with \3, \2, \1, that'll give us the last character, the middle of the string, and the first character, which just swaps the first and last. So what do we do with this? Regular expressions are just ridiculously powerful, right? If you're doing any kind of text processing. Like I said, Perl. Anybody here use Perl? Perl was really big in the 80s. It was sort of the back end of a lot of web pages, a lot of network infrastructure. And it was built largely around regular expressions. It's part of the basic syntax. Because regular expressions are useful for parsing input, right, and for modifying text, and that's a lot of what you do on web pages. But you can parse languages with this, you can write compilers with this, you can do all kinds of things with this basic structure. And it permeates a lot of different aspects of C and Unix. It's something that you bump into again and again. You can live a long and happy and productive life without knowing anything about regular expressions. Okay, it's not like a must know. But the more comfortable you are with them, the easier certain things become. And as usual, there's a whole bunch to regular expressions. This is a really tiny little subset, but it's a little kernel of the subject that seems to be useful for doing a lot of things, at least in stuff I've had to do. And if you like puzzles, as usual, it's fun because it's trying to figure out how do I take this small set of things and put it together in a way that lets me do, something more interesting. So, questions about this? All right. Well, we got 10 minutes. Let's go to the board. Let's just play around with some of these. So, oh, that's really hard. That's worse. All right, we're in darkness. That's okay. So I'll post this on Canvas, but let's just start with I don't know. Let's jump into registers. Let's see where we can go. So remove the first 3 characters and the last 3 characters from a line. Yeah, let's try that. So regular expression, you want to remove the first 3 characters and the last 3 characters from a line. And you want to keep all the stuff in the middle.
For the new when I'm assisting it just freezes.
to do with your main program.
I didn't.
Try running your main program and running on that, and I'll bet it'll hang.
Yeah, because when I combined it, it was okay, but when I assess it, when I go to the capital G, you know,
Yeah.
when I enter, it's just like,
Yeah, so write a main program, link it with your main program, and test it. See if it works.
okay.
No, we're removing the first starting the last three. Right? Oh.
You could say,
Alright.
see what you're doing. No, I don't know if you're allowed to say more than I can hear.
What now? What do you guys trying to do?
Remove the first three, the last three.
I think the word in
No,
Yep, good. That's right.
no, you need three dots, right? No, just kidding, just kidding. I'm staring.
Actually, let me see. Okay, yeah, that's right. Yeah.
Last three things?
So the two
The second one is swap.
yeah, probably the same for this one.
Why is it there?
Take the first one.
Yeah.
Yeah, I get that too.
Oh, okay.
Empty means nothing. You just have it out.
No, we're gonna be.
Don't get it.
All right, and if you got the first one, you can go on to swap the first two characters.
Wait, let me, yeah, let's figure it out.
Too good. Perfect.
Was that?
Yeah.
Also looks like
Yeah.
oh yeah, could be that too, yes. It's gonna be a full.
Oh, yeah. Oh, no. No, I think it'd be like
First letters with last three.
first two characters.
which is 2 dollars.
2 dots. So, wait.
Yeah.
How do you say?
You got that one?
Any line that starts with
Yes. So that's good. So just do it without you just said this. Yeah, you can just replace those first two with the second one. And it'll leave everything else alone. But that's really well too.
Are we swapping the first two characters? What was the origin question? You are the right track.
I think you would.
It doesn't
Yeah, that's the first character.
What was the question?
Swap the first two characters.
Okay, I thought supposed to start first two with last two.
Oh, yeah.
That'll be pretty much the same.
So think about that.
Can you just add
The line that starts.
Yeah. Right?
I agree with that.
Okay. Let's just
At least so far. one right past.
Oh, you went like.
Swap the first and last characters. No.
What is the last? Remove any.
Oh yeah, swap the first and last character.
The third question. The third question is remove. Remove any. Remove that from the line.
Swap the first and last character. First one fix yours.
Where is it?
The third, on the registry. Third line. Swap.
In the top or the bottom? Where?
The bottom.
That's basically,
Second from the bottom. Second area. Second paragraph. Third line.
Remove the first three characters?
We already did that.
We did?
Swap the first two characters.
oh no, I was just saying like
Swap the first and last characters.
No, the first one last? Look, where is it? I thought that you guys were talking about I didn't see that.
Well, the first two characters, the last three characters. No, first
No, it
two.
says first two characters with the last three characters. Basically just two dots. Two dots because the first two characters.
Oh, yeah.
He's having with three.
Oh, yeah, you're right. All right, time to go. Yeah. Oh. That? Yep.
That's why I also.
I got all the big ones. Yeah. But it's not used. Some of them. Actually, a lot of them. No, some of them too old to death.
Besides the original
What is
the C is for older streams. Not for no matter what, you can check. But for mine, new stream positions. We want to have much more. Even with I can do that for you want to keep it slow. Excuse me.
there should be two it's still slightly
Because when I compiled it, it's
while programming.
I feel like no problem. So when the end one is not good compatibility, it will give you 0 and give you an error. It's gotta be some I would say internet issue.
Right. The other side.
Anyways,
Issue.
Trying to split it up.
I mean, I combine it, nothing came.
Okay. Yeah.
Thank you.
Yeah. Let me know. Yeah, no, that's okay. But yeah, just let me know and don't panic if something happens. Tuesday or Wednesday. All right. Yeah, no problem. Okay.
Yes.
Okay.
Any lab.
Yeah, I just want to let you
Did you do the copy and paste?
They usually have a little white paper in the lab.
No, it's actually more just fundamental.
Esau and Scott
Okay.
and.
Let's go for
Wednesday. Right?
I'm just saying that.
I'll probably post about it.
Yeah.
What? I'll probably post about it in the group discussion.